Marshall here. Welcome back to the video version of the Realignment podcast. My guests today are David Adler and William Bonvillian. They are putting the meat on the bones of the conversation around bringing advanced manufacturing back to the United States. I've done a bunch of episodes, including yesterday's with Gil and Louie, about the need to return America's manufacturing innovation lead. But this episode and episodes that we're going to do moving forward are going to focus on the how we actually accomplish that. So for anyone looking to understand the actual practicalities of this issue, this is the perfect place to start. I've also linked their American Affairs piece, which talks about this issue, in the show notes as well. So definitely check that out if you want to learn more. Hope you all enjoy this conversation. David Adler and Bill Bonvillian, welcome to the Realignment. This is a cool opportunity to talk about, I think, one of the most important topics in the Biden era. And even if we extend back into 2015, the Trump era as well, I've got the latest fall issue of American Affairs, and the two of your piece, America's Advanced Manufacturing Woes, led that volume. So shout out to American Affairs and the work of Julius Krein. David, I want to just kick off by asking you a basic question that you kind of open the piece with, which is, why was there a taboo against industrial policy in the first place? Obviously, if you could define industrial policy too in that answer, that'd be great.
Sure. Industrial policy, in simplest terms, is altering the structure of the economy so certain sectors are favored rather than others. The reason the U.S. had a taboo, which was fairly recent actually, was it didn't really need to worry about industrial policy because it dominated global industry. It was the world's leading manufacturer. That's after post-World War II. Before World War II, in the 19th century, it was quite active in industrial policy in terms of how the railroads were built, in terms of huge tariffs to industrialize. And that's just the tip of the iceberg. I'll turn it over to Bill now to finish the thought there.
Sure. And Marshall, I'd make a distinction between, industrial economic policy, which we've long had in the United States, right? Price controls for agriculture, support for healthcare, Medicare, for example, long-time subsidies in transportation. David mentioned the railroads. Those are long-standing kind of American economic policies. But what David and I are really writing about is industrial innovation policy. And, what's that, right? That's working with David's definition of industrial policy. Let's create a subset. That's intervention by the government at the post-research stages. So government, for, longstanding reasons of market failure, has long supported the research stage because industry can't really capitalize on that. That's too risky, too long-term to support early research. But industrial innovation policy would mean not only government support for research, a longstanding policy, but also development, prototyping, testing and demonstration, then production, and then initial market creation, right? And those are all the phases that kind of follow when you're putting a technology into place. And it's a governmental role at one or more of those follow-on stages from research. So mainstream economics, and David started to drive at this and can say some more, but mainstream economics has long argued that government interference distorts markets. And therefore, historically, the U.S. stayed out of interventions post-research in its civilian economy. But at the same time, it was running a parallel universe, right? So it had a defense industrial policy, which really scaled up in the course of World War II, continued through the Cold War, continues now, where the Defense Department supported major industrial economic sectors. So the evolution of aviation, of nuclear power, of electronics, including semiconductors, computing, the internet, all of those sectors were essentially stood up in many ways by systematic government support at post, not only research, but post-research stages. So those are the big innovation waves of the past century, right? And the Defense Department had a big role in them. So On the civilian side, we avoid interference after that initial R&D, right? The government doesn't intervene after that, except on this kind of massive defense sector side. So the doctrine has been breaking down with the advent of industrial innovation policy, really in the last few years. There have been attempts over many years, and as David said earlier, history in the U.S. evinced industrial policy through things like the Whig Party. But really in more recent years, industrial innovation policy has really come to the fore.
That answer actually gets at an experience I consistently have when I interview free marketers who are dispositionally skeptical towards industrial policy. But when you talk about the supply chain issues, you talk about dual use technologies, you talk about advanced manufacturing or other advanced critical technologies, they say, well, okay, there's an exception in those categories. Bill, given the story you just told about the internet and a lot of those 20th century innovations, is it even useful to separate the defense categories from the civilian categories? Because once you actually integrate those two together, I see very little disagreement on the idea that the public sector or the government shouldn't have some form of input into driving outcomes in those sectors.
Well, Marshall, you're right. I mean, the reality is that we've had significant industrial policy. We just call it defense policy, right? And that's been ongoing for a significant amount of time. But there are sectors that are walled off that are not part of that, right? And one of those, and a crucial one, is manufacturing, as you write about in the book. So, coming out of World War II, the U.S. was, it was king of manufacturing. We had a mass production system that no country in the world was close to, right? We completely dominated production by the end of the war. Look, going into the war, we had 8 times the industrial production capacity of Japan and 4 times the industrial production capacity of Germany going into the war. You can only imagine what the numbers were by the end of the war, right? So we were kings of manufacturing. The last thing we had to worry about was a strong U.S. manufacturing sector. We had mastered this amazing mass production capability. So we didn't pay attention to it. And we didn't do R&D, and we didn't do innovation policy, and we didn't do industrial policy around manufacturing. Now, needless to say, our competitive rivals, of course, did. So Japan and Germany, I mean, look, after the war, they weren't eating, right? They had to get their industrial base back. They had to get employment back. So they developed industrial policies around that put manufacturing at the core of what they were doing, right? That was their innovation policy. That was what they devoted R&D to. And, as a result of that, they built very strong manufacturing sectors. And in fact, the next big innovation wave in manufacturing, after U.S. does mass production, starting really towards the end of the 19th century, after the U.S. does mass production, the next big one, Japan does, right? Which is the whole quality manufacturing revolution. And we missed it, right? We weren't paying attention to manufacturing. We assumed we were ahead and just kind of skipped it. So we didn't put our very strong American R&D innovation system onto manufacturing as a problem. We left that outside the door, right? The Defense Department was busy pursuing, things like nuclear power and aviation and the internet, but it wasn't paying attention to manufacturing. We just assumed that would always be there in the U.S. And of course, it wasn't. So by not bringing our innovation system to bear on manufacturing, we allowed a host of competitors, the latest is China, to really move ahead in those areas.
David, I'm really interested in Bill's use of the term "we" when it came to dropping the ball after the World War II era and kind of writing the early advantage into the ground. I think one could think of, well, the government could have focused on innovation policy, manufacturing policy, et cetera, but you also had executives at GM, Ford, et cetera, who didn't respond to the Japanese quality revolution by innovating in ways that they innovated in the early 20th century. They responded by outsourcing, et cetera, et cetera, et cetera. So where does the private sector come into that 20th century, mid to late 20th century version of the story, do you think?
In some ways, it checked out of this battle. To draw back to your distinction about military civil fusion, and aren't the military and domestic commercial sectors one and the same? They're not, in the following sense. When there is an invention or an innovation for the military can scale it up as far as it needs to, usually, not always. In the commercial or private sector, there'll be a research breakthrough, and then there's an assumption the last mile will be handled by the private sector. But in fact, that does not happen. There's a disconnect there. In terms of the US, it was just easy. I mean, I don't think, say, Detroit executives were aware of the new era they faced, and the US, was falling behind. But a lot of this still comes back to government failures. That the government did not construct an innovation system that supported the execution of manufacturing. It just assumed the private sector could handle it. And it turns out the private sector could not and would not.
So I guess the question then is, why was, and you correct me if I'm reciting this history incorrectly, but pre-World War II, if you're saying that already the U.S. manufacturing base had abilities and capacities that the Axis powers were never capable of matching, that suggests that manufacturing innovation was going on in the first place without the Vannevar Bush World War II era innovations of research and development, et cetera, et cetera, et cetera. So why is the private sector able to innovate in the late 19th century to early 20th century? Why does that break down after World War II?
First of all, a lot of their innovations still came from the military. If you go back to really the 1850s or 1860s, Army arsenals invented the ideas of some elements of mass production where there are replicable parts. So a lot of the innovations still always come from the government, going way back in time. But ultimately, the production used up to World War II was less sophisticated. It was not advanced production. It was really just assembly lines. So the US could get to the assembly line era where you needed unskilled labor working on the line and maybe skilled labor designing the production line. People like Japan and now China, to some degree Germany, are using and developing advanced manufacturing, which requires many more complex inputs in terms of execution and production. It's a lot less simple. And if you'd like a definition of advanced production, I'll turn it over to Bill, who will give us one.
You anticipated my question.
Let me step back a little bit, right? Why do we need this advanced manufacturing? Then I'll answer kind of what it is. But there's basically two ways the U.S. can compete with lower cost Asian economies, right? We can lower wages, that's going to be popular, or we can increase our efficiency, right? And unfortunately, U.S. productivity in manufacturing has been stagnated and actually in some cases declining for the last 15 years. What is advanced manufacturing? It's the ability to
I pause you real quick because I want to make sure people understand this. Could you make explicit what a decline in productivity in that case means?
Sure. I mean, productivity very simply is, making more with less labor input, right? So we're making things more efficiently. We're using our labor force and our labor supply more efficiently. And manufacturing historically has led productivity, and the productivity, as everybody on this podcast will know, is a very direct contributor towards economic growth. Increasing productivity means you're making more for less, and therefore there's a real savings, and that real savings can be distributed, across your population in terms of higher economic well-being. So manufacturing productivity is the big driver historically in post-industrial economies. You get productivity gains in services, but it's typically historically much slower, right? Services tend to remain much more face-to-face, whereas manufacturing can really scale up. So manufacturing historically is the big driver. Manufacturing productivity can be the big driver in your economic growth. And the fact that we've had slower productivity in manufacturing in the last 15 years or so is a big problem for U.S. economic growth and overall well-being. So what is this advanced manufacturing stuff? It's
Sorry,
essentially.
I have to pause you again because this is just fascinating to me. Why it doesn't make any sense given your explanation of productivity growth that productivity would decline, because during this 15-year early 21st century period you're describing, you have increased automation, the internet, digital tools, etc. Why would that happen?
We were introducing, mass production itself is a huge productivity gain, right? So we were introducing systematically major productivity savings, into the economy through manufacturing, through this whole amazing mass production system. And then, of course, the US has the other advantage. It's got a common market for like a whole continent, right? Countries like, Germany didn't happen to have that. They were selling into their own markets and to some extent beyond them, to a lesser extent. So the US had these big advantages. That's part of why it was able to nurture this mass production system. So going into World War II and certainly coming out of it, we had all the gains of this big revolution in manufacturing, this mass production revolution. But then the next revolution in manufacturing, the next big introduction of new technologies and processes actually didn't go to the United States. It went to Japan, and they got the productivity gains, right? And that was the big competitive period with Japan. So advanced manufacturing is essentially the introduction of a suite of new technologies and processes with the accompanying business models to support them that brings in, these new technologies. And the scientists and engineers argue that we're now on the verge of another big transformational set of changes in the way in which we manufacture things: digital production, robotics, advanced composites, materials, artificial intelligence, machine learning, biofabrication, photonics. There's a whole suite of these technologies that are poised to come into manufacturing. And this suite of new technologies we can call advanced manufacturing, right? Some people call it Industry 4.0. I don't think that's a broad enough term. It really is a suite of new advanced manufacturing technologies. Our competitors are moving on these, right? And we have been slower than we need to be to adopt them. And we have a particular problem with small and mid-sized manufacturers, which is almost half of US production, right? It's about 46% of US industrial output is from companies that are small, less than 500 employees. These companies don't do R&D. These companies are usually slow to pick up, heavy capital equipment. They're thinly financed. It's harder for them to scale introductions of new technologies. They're not picking it up. Our larger companies are doing somewhat better, but not a lot better. So, for example, robotics density in the United States is terrible compared to the density of robots per worker in a country like Germany. So these are real problems. If we want to catch up on manufacturing, we don't want to lower wages, right? Which we don't want to do, right? We can lower wages and compete. But what we really need is a big productivity boost. And we're going to get that by more efficient production. And we're going to get that by introducing these new technologies and the processes that accompany them and the business models that accompany them into manufacturing. And that's what we need to do. And we've been slow off the start.
Yeah, David, you had something you wanted to add a bit.
Oh, just
before.
to answer technically your question, yes, there's a blip upwards in productivity when the internet came on board, and so to 2005 in manufacturing. But then afterwards, it started to flatline, if not decline. As Bill just said, robot density is not widely used in the United States compared to, say, China. The United States is down there with, I think, Croatia, maybe Slovenia. It's really not a leader in robotics implementation. Business models do not support it. And I think the US is just really not focused on this issue. And finally, we should talk about international competition. It's not that lucrative to invest in these manufacturing processes. Companies are not rewarded for it. And we're facing competitors who are heavily subsidized and, in fact, use various types of subsidies to drive their success in manufacturing. So there's really no economic reason to implement these ideas. And then finally, our innovation system, as we've been discussing throughout, is not integrated in manufacturing. So new inventions in the United States, A, are not focused on manufacturing processes, and B, to the degree they are, the technologies don't end up in US manufacturing. They end up elsewhere. It's a legacy sector and somewhat marooned.
I guess the discussion of robotics brings to mind something the audience is probably thinking about, which is to what degree is the advanced manufacturing opportunity a jobs creation project, and to what degree is it just something a country should have to function properly from an economic growth perspective, from a resiliency perspective, but isn't quite going to. I'm thinking about this just because the Washington Post had an interesting critique of the Biden administration's sort of promotion of its like manufacturing boom policies, because they're pointing out that like you could have all these numbers, but it's not going to translate into a big specific manufacturing jobs boom in the way the equivalent may have been in the 50s, 60s, or 70s. So I'd love to hear what you think about that, David.
Is that, do we mention names on this podcast? Is that Miss Rampell?
Yes, it is.
So that's sort of that's like a thorny debate that goes back and back. This debate, say, was used in India, where India said, well, we shouldn't use advanced products. We should have all the villagers making little pots and pans. So India had a lot of villagers making pots and pans and became enmeshed in deep and profound poverty. So you could go either way with this argument. But for instance, when the US implemented ATMs, the belief was employment and commercial banking would collapse. In fact, it grew. Basically, you're raising the wealth of the country, and maybe it will move to other sectors, but it's sort of a win-win for the country rather than having people in lowly skilled, lowly paid, poor manufacturing jobs.
Isn't the argument you just made, though, like a lot akin to the arguments in favor of outsourcing in the 80s and 90s, in the sense that, like, yeah, we could have everyone working in these like low wage manufacturing jobs, but like ultimately outsourcing is going to make the overall country wealthier, and that will be distributed properly. And we do TAA. I'm just curious what you think about that.
I think that argument was made not naively by consulting firms who love doing outsourcing. It turns out the U.S. outsources its best jobs, not its worst. It's left with low-level service jobs. So I don't think the argument is synonymous or parallel. So the U.S., the whole idea of outsourcing was that the U.S. would somehow magically retain advanced manufacturing. And even today, you'll see a common argument sort of in the folk wisdom that the U.S., the reason employment is declining in manufacturing is because productivity is improving. That's a common idea that's out there. That idea is false. It turns out, we're going to go deep here for your audience, on statistical measurement of productivity. And it turns out the way productivity is measured in manufacturing relied heavily on one arcane fact, that as computers became more and more powerful, that was logged as a productivity improvement in manufacturing. So you had the whole US manufacturing system gradually sort of evaporating, in effect, becoming more and more decrepit, but you did have advances in computer power. So if you looked at the statistics, the argument was, oh, well, it looks like US productivity in manufacturing is improving. It was not. It was output in computer power. Computer power was improving, not manufacturing.
And Marshall, let me go back to your question. Aren't the robots going to take all our jobs, right? And the U.S. has had historical debates about productivity and job numbers. We do it about every 40 years or so. And there's always a big media press that there aren't going to be any more jobs left. There are going to be no more jobs. And the latest one we've had is around AI. But let's look at robots, right? So robots, no question about it, will eliminate some jobs, but they will also create new tasks and new spaces within existing jobs as employees learn how to work with this kind of new generation of robots, which are, they're cobots. They're in a way assistants to you, in a way like your iPhone might be an assistant to you, right? It's not that you're going to lose control to your iPhone. It's that it's an aid to you. And so there will be a suite of new tasks and new job opportunities that get created on the job as robots enter. And then third, there are going to be jobs created by making and programming and repairing and updating and placing these and delivering these robots into place as well. So we often tell the story of the robots will just straight take our jobs away. And that's part of the story. But there's also the fact that robots are going to create complementary job creating opportunities and new job opportunities. And we need to keep in mind that manufacturing contributes much more indirect jobs to the economy than other sectors. And why is that? Manufacturing scales, right? You make one iPhone and then you're producing 2 million the next month, right? In other words, manufacturing can rapidly scale up and therefore scale up a whole new suite of products that have to be supported and delivered and maintained and updated. So it's creating a flow of new opportunities through the economy in the kind of way that services which is much more face-to-face, person-to-person, right, is not, because services don't scale like that typically, with some exceptions. But most services don't scale. So the scalability of manufacturing really creates a lot of indirect job opportunities in the economy. So manufacturing historically is a much larger indirect job creator than the services sector. And that's why it's part of the reason why we need it.
I want to kind of jump around your really fascinating piece. We'll link it in the show notes, obviously, but something that the two of you wrote about, either you could take this question, depending who's more expert in it, is just your articulation of the workforce training issue. So something we're hearing right now of a lot of the, post 2021 industrial policy efforts is especially like in the semiconductor industry. We don't have enough trained workers who are capable of doing X, Y, and Z different tasks. And you two kind of go into a bit of history of the US vocational system. And the way that I typically, as a person who surveys narratives, not deep topics, is the way that you two do, you kind of hear remember in the 50s and 60s and 70s, how we had vocational education and it was so great. Look how bad the status quo today is. But you two actually write that actually vocational education in the 50s, 60s, and 70s was actually pretty not great, to be technical about it. And part of what drove us to the status quo no one's happy with was sort of ill-formed attempts to fix what was broken about that old system. So take us back to the 50s. What was the matter with that kind of heyday version?
I'll begin at the 50s and I'll let Bill talk about advances today. Back in the 50s, it was sort of, there's also a racial component that sort of certain students, often again with the racial component, were shunted off into vo-tech education. It was you're not going to go to college, you'll just go to shop. Furthermore, don't forget the jobs at the end of that process were just line jobs in the factory. They weren't very sophisticated. They did not require many skills. So it was not a great system. It was not producing great skills, but then again, great skills were not required in US manufacturing at that time. So that system was shut down for a variety of reasons, with the idea that you would have college for all, that rather than shuffling people off into the sort of dead end of shop, you'd send them to college. First of all, we didn't get college for all, but coming back to manufacturing, when they went to college, should they make it to college, college is not linked to manufacturing in the United States. So the US academic system is busy cranking out research and things like that, but they're not applying that to manufacturing. So that's an example of the disintegration or lack of integration in the United States between institutions like universities and manufacturing. So sending people away from vo-tech into college did not translate into any improvement whatsoever in manufacturing. And maybe you'll get into this before we give it, just to prompt you. The hostility among academics, the cultural hostility to manufacturing, and the idea of a post-industrial society. But I'll turn it over to Bill now, because there have been some breakthroughs recently in workforce or attempts at breakthroughs. So Bill?
Sure. I mean, a deep underlying problem in US education is the disconnect between school and work, right? There's not continuity between the two. You don't pick up background and career information and knowledge that will lead you into employment, right? We don't have a system to do that. A number of countries do. Germany, most famously, has a famous apprenticeship system, which consists of school and work. And they are integrated so that you are learning skills that you have to use on the job, which frankly makes learning much more accessible and involving for the student. And that apprenticeship system is very prestigious. And German manufacturing, which employs close to 20% of its workforce, American manufacturing employs about 8% of its workforce. German manufacturing is very high paying. German manufacturing employees earn much higher wages as well as benefits than in the US. And part of that is that they've got a very strong workforce education system. The US just never built that, right? We had occasional apprenticeship pieces here and there in the economy. Some larger companies had them for a time period, and there's still, a handful that have something left of those old apprenticeship systems, but not many. And the school to work disconnect is at its height when we dismantled vocational education, which was frankly not good education in a time period like the 50s and 60s. It was not quality education. It was a way of shunting lower middle class or working class kids off into a non-college track. We tried to reform that by shutting down most of vocational education. And as David said, by pretending we were going to send everybody to college, which of course we didn't do. So now we're stuck with an even deeper disconnect between work and learn. How do we get out of that box? Lots of experiments are going on. Fortunately, we have community colleges in the country that are well situated to kind of help fill this gap. And in many parts of the country, a number of them are really working to fill that gap in a very creative kind of way. And they are incorporating earn and learn programs. They're incorporating work opportunities into the curriculum that they develop in the community college. So there really is a connection with apprenticeships that America's community colleges are starting to try to emphasize. But we have a long way to go to carry this out. We're just at the early stages. And, you look at Germany, German manufacturers realize, we were talking earlier about productivity. German manufacturers understand that you get productivity in two ways, right, in manufacturing. You get it from capital investments, new plant, equipment, so forth, and you get it from your workforce. And the big German advantage in productivity, frankly, is that they realize that a workforce productivity gain is much more enduring, right? When you just invest in new capital and equipment, your competitor nations are going to catch up over time to those investments. They're going to do the same, right? But if you have a workforce advantage in productivity, that's enduring, that's lasting, that strong workforce that contributes to your productivity is an enduring relationship. So the field of innovation policy, R&D policy, has rarely looked at education as a factor in innovation, but it is, right? It is a big factor. And the quality of that talent pool, both at the technical level and the professional level, going into the innovation system is very key. And while the U.S. has got a strong innovation system, a strong innovation capability through its strong university system still, we really have failed at the secondary school kind of level and really need to rebuild that, I think, in combination with strong apprenticeship programs to create new kinds of opportunities. And work in the manufacturing sector, this is sophisticated work. This is not the Ford River Rouge plant in 1930, dirty, dark, and dangerous. This is manufacturing plants today are clean and highly technical and require lots of IT and computer skills. These are quite sophisticated jobs that require significant training to do well. The rote jobs, the stick something on an assembly line kinds of jobs, those were the jobs that went out in manufacturing. We lost 1/3 of our manufacturing workforce between 2000 and 2010. A lot of that story is competition. Some of that story is outsourcing. But so that the road jobs went away in that decline. What's left are considerably more sophisticated jobs with significant job opportunities behind them.
Okay, so this is where this is my favorite part of this topic, because I like when you talk about anything relating to education, it very quickly gets sociocultural. If we're imagining the ideal student for these apprenticeship programs, what does he or she look like at age 12 or 13? Because I think what's so fascinating here is we've had 15 years of like the you've heard it a million times, the like, we need to convince people to take these dirty jobs, like Mike Rowe reference. You can make way more money being an HVAC than being a failing college adjunct, et cetera, et cetera, et cetera. But like at a certain point, if that argument was going to be successful at transforming our sociological approach to college, I think it would have probably worked by now. But two, I think the part that's missing in that critique is that it's very much framed around treating the like dirty jobs, like HVAC alternative, as something for the people who weren't well served by the like current post 70s college status quo. Well, it seems like when you're talking about the prestige of the apprenticeships, the difficulty of the work and the nature of the work at these factories, this actually sounds like the type of work that like top tier, or at least like top half students would be kind of taking on. So how does that picture work together? I know it's kind of confusingly framed, but I haven't really thought of this way before.
Let me give you, and I'll jump in, David, and then turn it over to you, but let me give you a picture, right? What does this mean for a student, right? So, I spent some time in South Carolina looking at a youth apprenticeship program that had developed there, right? South Carolina happens to have a lot of manufacturers from abroad, right? Germany has landed big time into the South Carolina economy and is running a significant number of manufacturing plants, BMW, Mercedes, Bosch, and U.S. parts suppliers to those companies. And now Boeing has got a big facility not far from Charleston. But the smaller employers in Charleston were having trouble attracting talent, just the problem you described, to the jobs that they've got in this increasingly sophisticated production settings. And they came to the local community college in North Charleston called Trident Tech. They have technical colleges in South Carolina, not community colleges, but they're comparable. And Trident Tech agreed to kind of take on the problem, and working with a group of 6 smaller manufacturers, less than 500 employees, began creating a youth apprenticeship program. And the employers interviewed in 5 area high schools for students in those high schools that would be interested in potential manufacturing careers. And then, and they selected them. And this became kind of a prestigious thing in the South Carolina program. They have like a big event, right? It's like an it's like a pro selection of college football players. It's like a big celebratory popular event. It gained a certain amount of prestige. So the students in this program spend the morning in high school. And by the way, their employers tell them, you got to take math and science, right? Because they need that, right? Mm-hmm. And then midday, we all know what kind of a disruptive environment high school can be. There's a lot of self-destructive stuff that goes on in high school. We all know from our own experiences and having seen it, right? So they're in high school in the morning, but they're doing more technical courses. Then they're out of high school around lunchtime, and they are off to the community college taking technical courses for the skills that they need in their job, right? And when they go to the community college, they're not with high school age kids anymore. They're with the average age of community college students is 29. They're with much more mature, work-oriented people who typically already have jobs. They're already in the employment market. They're starting families. They're in a much more mature environment. And then in the later part of the afternoon, they go to their employers, right? And those workers, again, a much more mature environment. They're in the 30s, 40s, 50s, right? Mm-hmm. So they're out of that kind of self-destructive high school mode into a much more mature environment, getting a much more mature outlook. They're learning skills. By the time they finish high school, they have also completed the first year of community college. The employers are typically willing to pay the tuition of the second year of community college. So they're getting an associate's degree in a skill area. And they are in a quite sophisticated technical environment. They're not learning skills by taking math classes, right? They're doing applied math on the job. That's how to learn things. It's learning by doing, and that's what they're picking up there. So this, frankly, is transformative for these kids. And they're kings of the hill in high school because they're earning quite good money, right? And they work on weekends if they want to, and they work on holidays if they want to, as well as in the afternoons. So they're in a prestige status in their high school environments, and they're on a pathway to get the skills. And the whole barrier between work and learn in the U.S. gets broken down in this kind of system. Can't we do more of that, right? Can't we create these opportunities? And a number of these kids, having gotten their associate's degree, actually go on to their engineering degrees, right? And the minority participation in this program is over 40%, right? So this is reaching kids of poor backgrounds, right? Not just middle-class kids. This is reaching well below that. So it's a very interesting story. And South Carolina is now attempting to do these youth apprenticeship programs statewide. It has a bunch of German employers who understand, frankly, what an apprenticeship program is, which is helpful. But their U.S. suppliers are falling right in line. They see it too.
Anything to add, David?
That also goes back to your earlier point about, well, would advanced manufacturing cause a decrease in jobs? What this is showing that if you really want good jobs in this country, that's kind of, you need to look towards advanced manufacturing. Part of the reason for the growth of inequality in this country, the stagnation in jobs and wages, is related to the deterioration in the U.S. manufacturing sector. And to throw a bone to you, and the rise of a neoliberal solution instead.
And I think for this last section, I'll throw this again to you, David, just because the start of the piece really sums up the, let's say, like top level industrial policy approaches under the Biden administration as such. So you have the CHIPS Act, you have the executive order on biotech and biomanufacturing, you have the Infrastructure Act, and you have the Inflation Reduction Act. I'd love to hear what your assessment of those policies are, and then what is missing if we go a level deeper, as we have on this conversation, from that picture.
First of all, I think it's an incredibly encouraging change of events that the United States is suddenly in a more systematic way approaching industrial policy in certain sectors. So at a very high level, what's missing, if we began talking about linking innovation and manufacturing, yeah, the U.S. is throwing money at certain sectors, which is critically important and maybe the key friction that's causing the U.S. not to move in this direction. But there still has not been a full-blown readjustment of the U.S. innovation system to support manufacturing. One. Two, there are many, many sectors missing, and I'll turn over to Bill to discuss them. Many, 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 many sectors that are missing. And what these sectors have in common, quoting our editor, Julius Krein, is they don't have a lobby. So CHIPS is a lobby. Green is politically powerful, but there are many kind of nascent sectors that do not yet exist. So by definition, there's no lobby for them. And right now, there are not industrial policies across the board hitting every single sector. We can also talk about the Trump administration's industrial policy rather than policies. There's really, the Trump administration, as you know, did tariffs, but it really didn't do industrial policy, except for, it was always trying to cut the manufacturing extension partnership because there's a lot of Reaganite ideological residue in the Trump administration. But the big exception was warp speed. And warp speed is interesting because it illustrates all these things we've been talking about, how the U.S. innovation system, the defense innovation system, how the U.S. basically has problems at the last mile. It invents things that does not go to the last mile. So going back to warp speed, DARPA, and I've written about this a lot, helped create mRNA vaccine technology. And the reason they did that is they knew that traditional vaccine technology, where you sort of grow a host in an egg or try and develop something, took months and years, months. But if you have troops in the field, you need a vaccine very, very quickly. And people at DARPA had this novel breakthrough insight. They're like, oh, well, maybe we could use mRNA to sort of have the body build its own vaccine, so to speak. They began exploring it. There's some preliminary positive work. And then what happened next? Nothing happened next because innovations do not scale in the United States because there's no financial impetus to do so. The U.S. financial system does not do so. The U.S. funds basic research, but does not adequately fund applied research. So nothing happened until the COVID pandemic hit, and suddenly there was a need for it. And suddenly things clicked into action in the Trump administration and basically scaled up this mRNA vaccine technology. So that's an example of how you could solve some of the innovation problems presented throughout the United States, but that's just one example. So who knows what else is out there that the US is sort of fumbling around and not doing enough with, because universities are creating new research and then it goes nowhere.
And I can add to that, Marshall. There have been a host of policies, and you named some of the major pieces of legislation that have passed in the Biden administration, but we haven't adequately put the industrial into industrial policy yet, right? So back in the Obama administration, and it was continued in the Trump administration, but not expanded, we created a series of 16 advanced manufacturing institutes that were organized to try and do the research and demonstration, really, of the development and demonstration, really, of a suite of advanced manufacturing technology. So there was a manufacturing institute around robotics, one around digital production, and so on and so on, right? 16 of these, located in quite a dispersed kind of way around the country. But that program never received adequate funding and support. And when it was created, it was put on a term limit. The federal government money was only going to be available for 5 years. So these institutes, as soon as they were created, had to start worrying, wait a minute, this problem is not going to get solved in 5 years. You don't do an industrial revolution in 5 years. It's a longer term project. What are we going to do in year 4, right? What are we going to do in year 5? So they turned to support from larger companies, which means, as I talked about earlier, the biggest problem in U.S. manufacturing is with these smaller firms that are slow to adopt new technologies and advances, right? They're thinly capitalized and they don't do R&D. So they're not reaching, the institutes were kind of forced by this term limit to kind of serve their larger customers, their larger firms, and leave out the smaller firms. And in addition, they were under-resourced for workforce development, another critical input. So we've got underfunded manufacturing institutes that we really need to scale up. But there's other things that we need to do too. And David has hit on this. We really need to provide a mechanism for technology scale-up financing, right? In comparison, China spends, in equivalent US dollars, about $400 billion a year to scale up manufacturing production, right? That's an absolutely critical difference between where China is on manufacturing and where the US is, frankly. We don't have mechanisms to do that, and we really need them. We need to do a much better job at mapping supply chains and understanding where gaps in supply chains are. We need to have much better facilities for testing and demonstrating new advanced manufacturing technologies. There's a host of new policies that we need to put in place. And David's point that we need to better connect the innovation system, R&D and development stages, the government does support. We need to better connect them to advances in manufacturing at a larger scale than we're doing now. U.S. R&D agencies don't even have manufacturing as part of their agenda. They need to.
So for the last question, you both can take a stab at answering. I host another podcast at the Hudson Institute called Arsenal Democracy. And the week that we're recording this, I had one of my Hudson colleagues, Dr. Nadia Shadlow, on, and she helped write the National Security Strategy in 2017. And she just wrote a recent Atlantic piece, which is basically, in all of this type of conversation where we're having here, her frustration is we frequently don't have a sense of either urgency or a sense of timing. So, for example, a policymaker could listen to our conversation and think, okay, yeah, like we should really scale up apprenticeship programs a la South Carolina, or we should like enhance the American innovation system. What actual timeline / sense of urgency should we be operating under if we're going to talk about these issues? Because my frustration personally is I hate having conversations that you could have had some version of in 2018 and getting the sense that nothing would be any different between those two periods. Not that you guys haven't been fresh and interesting, but obviously like we could have had a version of this. Something obviously didn't happen in the like 6 years in between. So I'd love to hear what you two think about that dynamic. David, please.
Right. Yeah, we know what happened. China happened. China's changed everything. And in fact, if you want a sense of urgency, wasn't there a comment by the United States Secretary of the Air Force? In fact, there was a comment by him saying that China is preparing for war in the United States. The United States that sense of urgency is people who do defense, look at the defense industrial base. They don't always, sometimes they do, think about the entire industrial base. The United States arguably won World War II because it had such a, as we said at the beginning of this podcast, such a massive industrial base advantage over its competitors. The United States does not have industrial base advantage over China. It has a smaller industrial base than China. China is the urgency in the situation. And even aside from war, I'd like to get into some of the details here, which is China. We've been talking about the US needs to reinvigorate its innovation system. China is doing that. Even though people poo-poo China and saying, well, China's in a sense of decline, that may not be true. That might be true in Chinese real estate, but Chinese industry is still rolling ahead, as we can see by its dominance as the world's largest auto exporter. And China is rethinking its innovation system in a way the United States needs to do. So it's doing basic research now, the way it did not historically, but it's also doing more applied research. So in a way, the end of this podcast, I'm going to say the unsayable and the unthinkable. Maybe we should learn from China.
Well, and just quick thing, because I don't like how the Chinese real estate issues have been kind of weaponized by China doves to basically mean we shouldn't care, because the U.S. went through the Great Depression literally right up until World War II. That didn't mean that River Run and all those other like industrial capacity potentials were capable of being leveraged in a different direction when the stakes were high. So I'm just sidelined, frustrated by that. But Bill, do you want to close us out on the episode?
Yeah, I think that advancement in manufacturing needs to be a front and center policy for the U.S. And for sure, this is a competition with China question, no question about it. But it's also very much a question of our own economic well-being. When we laid off we fired 1/3 of our manufacturing workforce between 2000 and 2010. And by the way, we haven't gone back to, I think in 2018, we finally get back to our 2000 levels of industrial output. That was a big hole in the system, and that created a really an economic failure for America's working class that was the ramifications of which are still playing out. A lot of the political disruption we see today, and certainly the economic inequality, the growing economic inequality, can be traced right back to the failure of this country to get on top of manufacturing and keep that as a strong sector. It was historically the great driver of the American economy. As we've seen from East Asia, that's the great driver of their economies. The neglect that we've gone through in manufacturing has had painful results. It's created national security problems for us, for sure, but it's also created very serious economic inequality, and political disruption problems too. So there's a lot of reasons why we need to tackle this issue.
That is an excellent place to end. David, Bill, thank you so much for joining me on the Realignment. And once again, to all listeners, I recommend you check out the American Affairs piece that we referenced during this conversation in the show notes. Once again, thanks again for joining me on the show.